Okay, friends, let's take a look. So we want to find the derivatives of exponential and logarithmic functions. So our first task wanted to derivative of e to the x. So when we're doing derivatives, we got to start with the limit. Well, for some of our derivatives, we'll see some stuff. So it's f of x plus h. So we're printing that f of x is e to the x. So e to the x plus h minus e to the x all over h. Now, back in the magical algebra land, we learned that we could rewrite that e to the x plus h as e to the x times e to the h. Now, what do you think we're going to do? Let's see, let's think. Oh, it's one of my favorite things to do, which is factor. So I'm going to factor out an e to the x. And really, I'm going to put it here, but I really could put it out front of the limit. So I factor that out. And really, if I wanted to, I could take that e to the x, and I could say, I'm going to put it in front of the limit. I'm going to slam it right there. Not enough room, but that's okay. So now I just need to consider this limit, e to the h minus 1 over h. Now luckily, right over yonder, e to the x minus 1 over x, I gave a graph here. The limit as h goes to 0. Well, from the left and from the right, this is going to equal 1. Now, if you plugged in 0, you would have 1 minus 1 over 0. That doesn't work. So really on this function, there's a hole at 0, 1. But the limit still exists because the left and the right side are the same. So now, let's look at what we just figured out. The derivative of e to the x is, drum roll, e to the x. Oh, it's its own derivative. It's like magic. So we did e to the x. How about natural log? So I have a couple questions there that hopefully you're pondering right now. And hopefully you understand how to do this. And you can do it all by yourself. Don't worry, I got you. You can also write this as, aka, y equals the log of x base e. And hopefully you learn some stuff about logs so that you know you can rewrite that as, that looks like g, that's a y, I'm sorry. E to the y equals x. So that's the biconditional statement that works with logarithmic functions. If you have no idea what the heck I am talking about, feel free to ask about that. So now we have e to the y equals x. Well, let's take the derivative. We just learned that the derivative of e to the x is e to the x. So the derivative of e to the y is e to the y. But wait, I have to remember chain rule. Because on e to the x, there was an x in the exponent up here. But now it's a y. And since we're taking the derivative with respect to x, we need to also do the derivative of the inside, which in this case is up top, it's the y, so I need a dy dx. Don't forget the derivative of the right side. The derivative of x is just 1. So that means dy dx is 1 over e to the y. That's not that pretty. But what's another name for e to the y? Look at the purple line. Look at the purple line. It's just x. So the derivative of the natural log of x is 1 over x. Ooh, let's generalize. Okay, so we have y equals a to the x, y equals log of x base a. I'm pausing. I think I want you to try these and then ask me about them. I think that would be better. So try these and ask me. Don't worry, I got you. I'm going to give you some hints. My hint on that one would be, it would be nice if x were not an exponent. And my hint on this one is, it would be nice if a was not the base. So there's two different ways you can kind of process through that. Totally up to you. Play with those and let's see what happens and talk to me about that.